People are dying. ICUs are reaching their full capacity. Restaurants, schools, and so many things are closing down. But in the midst of all this chaos, Dr. Alexander Wong from the University of Waterloo and other researchers came up with this project called the COVID-Net Project. It has many use cases, one of them being how it leverages artificial intelligence to detect whether someone has or does not have COVID-19. Hi, my name is Prisha and I'm really interested in artificial intelligence and its medical applications. Specifically, as of right now, how it can be used in medical diagnosis. I recently read a paper called Performance or Trust? Why Not Both? Deep AUC Maximization with Self-Supervised Learning for COVID-19 X-ray classifications, and it was so interesting. The research paper was rooted in a problem of compromise. A compromise between performance, the accuracy of a model, and trust, the level of bias presented in a model. Bias is a systematic error caused by a wrong assumption in the machine learning algorithm's modeling. Sometimes the model learns from wrong signals, not considering all the data points, or drawing wrong signals and patterns from the data points. And this sometimes leads to missing relevant relationships between data inputs and predictions. Essentially, bias can happen when the model doesn't have proper capabilities to draw right patterns from the data set. So they were trying to create a neural network that would detect COVID-19, and because of this application, it was so essential to not compromise between performance and trust, because it was a question of life and death for many. To not compromise performance or the accuracy of the model, they use self-supervised learning. It can be considered as a middle approach between supervised and unsupervised learning. Supervised learning is learning where you input data that is labeled, where unsupervised learning is you input data to the model that is not labeled. So for example, if I wanted a model to detect between dogs and cats, in supervised learning, I would say, when I input all the data, as an example, that this is a dog picture, this is a dog picture, and this is a cat picture, this is a cat picture, this is dog, cat, whatever. Well, with unsupervised learning, you don't necessarily have those labels. So they took the middle approach, where their majority were unsupervised images. And to optimize the trust and not compromise with the trust, they took another approach. Usually what happens is that models are optimized on the cross entropy. However, what that results in is the model being overconfident in its incorrect predictions of the majority class and overcautious of its predictions in the minority class. So when I say majority and minority class, it's essentially majority class is the larger sets of data, and the minority class is the smaller sets of data. So if I had, let's say I'm detecting breast cancer, and if I had a lot of the data related to malignant tumors and very little data related to benign tumors, malignant tumors data is a majority set, and the benign tumors data is the minority set. So before going any further, what does entropy mean? Entropy is the measure of disorder or randomness in a atomic or molecular system. This is in physics. So in other words, a high value of entropy means randomness of a system is high, meaning it's difficult to predict the state of the atoms or molecules in it. Or on the other hand, if the entropy is low, it's much easier to predict that state. This is a definition in physics, and if we want to apply that to machine learning, it's a similar concept, because entropy is also the measurement of the randomness. The lower the entropy, the more accurate the prediction of a model is going to be. The higher, the less accurate it's going to be. So you can see the problem here. To optimize on the cross entropy, the model is going to be overconfident in its data. That's what I mentioned previously. Overconfidence is a result of overfitting. And what overfitting is when the model finds patterns in the training data, but those patterns don't really reflect the bigger picture of the data that's actually there. So to eliminate this, they investigated a new surrogate loss function called Deep AUC Maximization. And they integrated that with the self-supervised machine learning model. So that way, the performance is really good, and so is the trust, and there doesn't have to be a compromise between the two. So they not only found this, but they found two other things as well. Firstly, they found with experimental results that the self-supervised model had improved model performance than just supervised learning models on screening COVID-19 patients. The second thing they found was a new surrogate loss function, so the deep AUC maximization, can produce models that are more trustworthy than those optimized with the cross-entropy loss. Overall, this was super interesting to read because as I'm making projects in AI, I'm getting a real-world perspective on how AI is actually helping us and the challenges and drawbacks that AI sometimes has. So for example, the compromise between performance and trust, and how people are trying to mitigate that by the new surrogate loss function and self-supervised learning. And that's super cool. This was just a very short summary on this paper, and the paper goes more in depth on the architecture and how they specifically did that, the data sets used. Totally recommend that you read it. Well, that was it for this video, and if you like the video, make sure you like, share, and subscribe, and be sure to hit me up on Medium, hit me up on LinkedIn, hit me up on Twitter, and I'll see you back with another video very, very soon. Bye!